Welcome back. In this lecture, we will start to discuss everything about hair organ, which is the organ of balance and sound. We have looked at everything about eye in the previous lecture, so let's try to understand the overall structure of hair. The hair is an organ of sound and balance. We use it to hear words, and everything concerned to the sound have to do with wave. So this is the structure of the hair of human being. If you look at the structure, you will see some things that you already know. This is the pinna. This is the pinna, outer part of the hair. This is the external auditory meters, where the sound wave will pass through to hit the tympanium. Once the tympanium is heated, the sound wave will be transmitted to the hair bones, the three ossicles of the hair bone, the malleus, the incus, and the step. If you look at the diagram very well, you will see the patterns of how the three bones are linked together. This is the malleus with the hammerhead that stick into the incus. The incus is at the back, attached to the back of the hair drum with three tissue, and at the leg of the malleus, at the leg of the incus, attached the step. So we call these three, malleus, incus, and steps, the ossicles of the hair, which are the bone of the hair. At the inner part of the hair is semicircular canal, which is the one that actually determines the human balance. You can see it is 3 dimensions, and it determines the 3 motions of the hair: the roll, the pitch, and the yaw. That is, if you feel like you are down, you rotate or you rise, it will determine the 3 orientation motion. Here it is the cloaca. The cloaca, like a snake structure, this is the region where the sound is interpreted as what is interpreted as well, what is sent to the brain, so where it is interpreted to what we heard. There are some nerves, there are some receptors in this place that receive the sound from where it is transmitted from the steps to where it is passed to our brain through the auditory nerve, which is known as what? Cochlear nerve. So this is where the sound is interpreted as what we hear. This is what maintains human balance and determines our orientation in space. We also have facial nerves, or like that. These are the bones of the skull, where those organs lie inside the head. So this is everything about hair. It's very simple. We are going to look at this particular hair, and we are going to look at what are the parts that are very important concerning the hair and balance. We are going to look at the order of hair movement and the order of this particular ossicle. You have seen that malleus, incus, and step, it is mis, M-I-S, mis, or sim, S-I-M. It depends on the direction you take. If you take the direction from the cloaca, it will be sim. If you take the direction from the pinna, it will be mis. So just know that key point, you'll be able to understand something. There is another one, eustachian tube. This is the part that leads to the esophagus. This is the part that enables you to perceive the taste of anything that you put into the air, because it will link from this place down to this place. So this place leads to your esophagus. So therefore, let's go and see what air is like in nature. So this is the sketch diagram of the hair, the one that you can draw in your exam, and this is how everything looks like. So we have the outer part of the hair, we have the middle part, we have the inner part. So what is in the outer part the pinna as well as what external auditory meatus. What is the inner part? The hair ossicle. What is the middle part? The hair ossicles, the 3 bones of the hair. What is the inner part? The cochlear, organ of air, and organ of balance, as well as the auditory nerve. So this is the overall architecture structure of the hair. We have the outer, we have the middle, we have the inner. In the outer, we have pinna, we have the external auditory meatus, we have the tympanium. In the middle, we have eustachian tube, we have the malleus. Inside the eustachian tube, that eustachian tube region, we have malleus, we have incus, we have stapes. Inside the inner here, we have semicircular canal, we have cochlear, as well as auditory nerve. This is for this balance, this is for the hearing. So let us now look at the outer part of the ear. The pinna helps us collect the sound wave and direct the wave into the external auditory meatus. Those with large pinna and can move their pinna. It can detect sound in different directions, but not human being, because your pinna is small and you don't have power over it to move it in different directions. This is the power that a dog have that can perceive the smallest sound and it will respond to it. And we have external auditory meatus, which is the passage that links the pinna to the middle here. You heard that. We have tympanium, and causes the air ossicle to vibrate, good, which is the sender of vibration to the middle hair, thus transmitting the sound to the middle hair. We also have middle hair. In the middle hair, the air is eustachian tube. This is the passage that links to the throat and it allows air to enter the middle ear, so that the air on both sides of the eardrum can be equal. What they are telling you is that if you look at the diagram of the hair mainly, if you look at the diagram of the hair on this side of the eardrum, the hair of this side of the eardrum must be balanced. If it is not balanced, you are going to feel pain. Are you getting me? So if you are feeling pain and you swallow a hair through your throat to the eardrum, so the hair along that part will be balanced and the pain will disappear. So therefore, that is the function of that eustachian tube. Is very, very powerful, but it seems little to some people. It contains the hair bones. That is, the eustachian tube contains the hair bones, the 3 ossicles, which are malleus, incus, and stapes. Malleus, one of the ossicles that link to the eardrum, and it is a middleman between the eardrum as well as incus, so, and transmit the sound wave to the middle hair. In the middle hair, the incus is one of the 3 ossicles that link the malleus and the stapes, while the stape, it is one of the ossicles that link the cochlear, where the sound wave is converted to nerve impulse. So the sound wave is converted to nerve impulse in the cochlear. So this is the inner hair. In the inner hair is the cavity in the skull. It consists of cochlear. It is coiled tube filled with fluid called endolymph. Inside the lamberate, that is many parts, the lamberate, the many parts with sensory nerve. So we can look into the cochlear. In this diagram here, you can see what it looks like. So in that diagram, one of those things that you can see is this particular separator wire-like structure and 3 regions here. So we have this region is called scalar tympani. This region is called scalar media, organ of Coty. This is organ of Coty. Okay. We also have scalar vestibular. So that is to say, we have 3 scalar. When it comes to cochlear analysis, we have scalar vestibular, we have scalar media, we have scalar tympani. The scalar media, it is the one that is in the middle, and that is the cochlear nerve, the one that is attached to the organ of Coty. So the organ of Coty is located in the scalar media. Please remember this structure is very, very simple. So the lamberate, that is the lamberate, this part that we have in the cochlear, the 3 channels. They are the one called lamberate, with the sensory nerve that that convert the sound wave into nerve impulse. So this is cochlear nerve that convert the sound wave into the nerve impulse. So it is divided, it is divisible into three parts. We have seen that. We have seen all these three parts: the scalar vestibular, the scalar media, and the scalar tympani. The cochlear canal is roughly triangular, and its cross section resting on the basement membrane and extend all the length of the cochlear canal in the organ of Coty. So all the length along the length of the cochlear canal. Along the length of the cochlear canal, it is the organ of Coty. You can see the organ of Coty. It is one that is directly linked to the cochlear nerve. The semicircular canal is that has three orientation channel tube for the three type of motion: when you fall, when you rotate, and when you rise, the pitch, the roll, the yaw. So this is the whole structure. It has what we call this is a part of it of the cochlea. This is part of the cochlea. This is the inner part. So it has the vestibular system. There is ample around this place. So let us say it is the organ of balance. Semicircular canal is the organ of balance that enable organisms to detect their orientation in space. This tube projects three arms that sense different orientation: the pitch when you fall, the roll when you rotate, and yaw when you rise. The vestibular nerve carry the orientation impulse to the central nervous system just where it will be interpreted to see where you actually are in the space. So that is everything about sound, but there is something that I really want to talk about. How do you hear? You hear sound because whenever the sound wave is picked up by the pinna, it will be transmitted into the external auditory meters. This wave gets killed off in that area. What the wave will do is that it will cause the vibration of the tympanium. It will cause the vibration of the tympanium. Then that vibration will continue by the three ossicles, where it will be transfer into our cochlea. So the fluid inside the cochlea will vibrate and collide with the organ of Coty, where it is picked up. The organ of Coty will convert the vibration into what we call nerve impulse, where it will be interpreted in our brain. High pitch sound make the basement membrane near around the window vibrate more. High pitch sound, they are the P sound that are very high in nature. So, and then for every organism, the range of our hearing is about 40 to 1,000. It's 40 to 16,000 cycles per second. The range of our hearing is within 40 to 16,000 at Hz. 40 to 16,000 hertz. That is the range of the sound that we can hear. It is more than that for dog because they have large ear. So we have binaural hearing. This is because the sound, we can hear sound with the two ears. We can hear sound with the two ears. That's what we call binaural hearing. binaural, binaural hearing. That is to say, the hearing of sound with the two ears. That is everything about our hair. I know as a human being, there is a way you care for your hair. Do not put any sharp object in your hair. It is very, very dangerous. And do not try to put anything to your hair. If it's going to your hair, it can germinate and grow. If you want to clean the hair, please find a very soft cotton board. Do not find the one they deal with your stick with a very rigid stick. It can damage your tympanium. Find the one that is very soft to pick up the waxy substances out of a hair. Sometimes my experience enable me to know that if the wax is too much in your hair, you are going to be feeling a kind of tiny noise in your hair. This is because of excess amount of wax, and if the wax is too thick in your hair, the cotton bud may not be able to bring it out. If you want to bring it out, one of those things that you can use is to use hydroxyperoxide. Go and get it in chemist. Just put a little at a time. The hydroxyperoxide will go into the hair and ooze out the hair wax. Once it does that, just bring down your hair to it gets down the remaining hydroxyperoxide until all the wax is being removed. You have to make sure that your hair is clean. Don't put sharp objects, because it's one of those things that can lead, if care is not taken, it can lead to total deafness, and may God forbid evil. If one of the problems that can lead to total deafness is inability of the ossicles to vibrate in the hair. If you experience that, please, I will not experience that, I know, because it's very rare condition whereby the ossicle does not vibrate. Hair pressure is very, very important to be balanced. That is the reason why the eustachian tube and the eustachian tube canal, as well as external auditory meatus, is there for us to let air into the both sides of the tympanium. If the hair is in one side only, you are going to feel pain, and the pain can be eliminated if you swallow air through your throat that will go into your eustachian tube. So it will make the hair to balance, and you won't feel any other pain again. So this is what's very important in all the structure that we have been studying. It is the part of the light in the eye, it is the part of the sound in the hair, how sound will travel. All those parts are very, very important, and you know them. So here it is the nose. It is the organ of the perception of chemicals. What happens is that the chemical will enter into the nostril, and it will dissolve in the upper palate to be picked up by the sensory nerve. These are the sensory nerve. The sensory nerve will send it to the olfactory lobes. When the olfactory lobe is directly connected to brain, where it is interpreted, maybe you should wait, maybe you should pick race, because if your friend farted strongly at the initial point, beginning to who farted? So your friend will just keep quiet. Although I must let you know, it is very good to perceive smells of fart, but you don't know what is behind it. Let your friend fart well so that you can perceive it. So that is about that. About nose is very simple, and this is the inner part. But you can see the structure of olfactory tube. You can see how the sensory nerve is connected to the olfactory lobe in that place. It's very, very simple like that. So let's move on. Let's move on. I think there are some things that we still need to look at. Yes, taste of organ of taste, tongue. It is the organ of taste, and it has different region as well as label diagram. This is the label diagram for the tongue. If you are to label it, you can see that is your tongue. You can see this particular glottis in this place. Okay, look at the back at this place. It has many pillars. Pillars are the small lobes. These small lobes, they contain nerve ending that link into the organ that carry taste to the brain, or we call them taste bud. But the size of the lobe vary along the nose, along the tongue. So we have this one called valate papillae. When you hear the word papillae, it's not papillo. You can use papillo to remember papillae. Papille means feeling, to feel something. Are you getting me? So valate papillate. We have foliate papillate. We have fungiform papillate. We have piliform papillate. So all these papillates, they are the one of the most technical thing that gives UTME students difficulty, because when it comes to exam, many of them will not even know how it is arranged and where what is found. You start from below, go to the above. F, 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 V. F, 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 V. That is F3V. All of them is papillate, filiform, fungiform, foliate form. This is foliate. Folia means leaf. Fungi from the word fungi. White, fungiform. While filiform is one of the smallest aspects of those pili. They are connected to the word taste bud. Now here, it is generally accepted that there are 4 taste sensations. Recently, the 5th basic taste has been determined. We have sweet, we have sour, we have salty, we have bitter. Sweet, sour, salty, and bitter. And the recent one is called umami. Do you hear that? Using Asian kitchen produce by monosodium glutamate. Although you don't know the monosodium glutamate, glutamate is one of the amino acid, and attachment of one sodium to it make it monosodium glutamate. We are still going to look at that when we will study large molecular structure of large molecule. So we have salt, we have taste, we have sour, we have umami taste, cause depolarization of the taste bud. You see, they can ask you which of these does not cause the depolarization of taste bud. These are the key points they can ask you when it comes to tongue structure. We have salt, we have sweet, we have sour, we have umami. All these 4 tastes, you know, the last one is salt taste. Okay, they cause the depolarization of the taste cell. Although different mechanisms are applied. Bitter cause an internal release of calcium ion. No external calcium ion is required. No external calcium ion is required. That is the reason why. And calcium ion is one of the most important ion that solidify bone, that make our bone stronger. That's the reason why take bitter leaf, take bitter cola. They are good, but not too much. Okay, at times it will make your system refresh. It will refresh your system. Okay, so these are the different taste region in the tongue. That is your tongue. Okay, it is very important that you wash your tongue very well. It's one of the major delicate organ in human being. That is the salty and the sweet in the front, the sour on both sides, the bitter at the back. So in this place is the new one that is discovered called umami. But previously it has, I don't know, maybe it has been totally established. Okay, so that is that about our tongue. So this is our taste bud. I told you that each of the papillae that we have is directly linked to the word taste organ, which is the taste bud. And inside the taste bud, there is oral cavity, which this is the mouth hole. This is the tongue. This is one of the hole. Or this is one of the papillae hole. That is the taste pore. Pore means hole, passage. So this is the lingua epidelia. This is epidelia. Epi means upon, delia means cover. Lingua means tongue. That's where we start the word lingua franca and the word language. Language means state of tongue. This is taste receptor. This is the taste receptor. You can see that it has 2 nerve endings where those tastes can be received, and this is the taste receptor. It is a cell. Okay, you can see that it is a cell with a very large nucleus, and this is the basal cell. This is the basal cell. The basal cell does not have the upper nerve here, but it is partially connected on the efferent nerve. Efferent nerve is the one that carry signal towards, and efferent. If this one is E, it means away. If this one is A, afferent means towards. If it is E, it means away, means efferent. These are the connective tissues. So this is the nerve that transfers this taste to the brain for interpretation. Please, for white students, learn how to draw this taste bud, because it's one of those questions they can ask you. For UTME students, please identify and know the different parts of this particular taste bud. They can ask you to identify the parts. This is the end of everything about sense organ. In the next class, we are going to start discussion on nervous system. After nervous system, we are going to discuss endocrine system. These are the two major things that has to do with transmission as well as a reaction, that is the action that we produce by the brain to any particular stimulus that is picked up by the sense organ. So we are going to discuss both nervous system as well as endocrine system in the following class before we discuss everything about reproduction. Thank you for listening. ABP.